Hello, good afternoon, everybody. I think we can start right now. Mostly people have joined us. Uh, this is Muhammad Abdullah. I'm your presenter today, and we were discussing a, a topic which is maybe from the past few years we are trying to discuss on it. It's a comparison between MIDAS and the SpaceGass. We will try to be very not to be biased on each and every software, like maybe uh, and I will definitely not we are not here uh, to say which software is bad or which one is good, but we will discuss the good points which is helpful for the engineers working in the industry, and uh, some time-taking procedures for the other softwares. So we have contents for this presentation, like um, like I have done some of my introduction before, and I will um, give my proper introduction in a coming slide as well. And there's an overview of space gas and general discussion about the space gas, and then we will discuss limitation of the space gas, like there are some limitation of space gas when we are working on the software, and some useful things of space gas and MIDAS as well. Yeah, so there's some useful information about my company and about myself. Becca is one of the Asia Pacific largest company. We are doing consulting and design work for a century, maybe uh, for and we have more than 3,300 employees in Becca. And myself, uh, my name is Muhammad Abdullah. I'm a structural engineer and working with the Becca um, in a structural team, and I have a working experience of more than 11 years. I have Previously I was working with some other Australian company, and before uh, moving here in Australia, I was working in Canada, and I have some experience of Middle East and Pakistan as well. Um, I was engaged in working in Australia in some Monash Freeway Stage 2 upgrade project, replacing a bridge in Ovalu, which is in Fiji, and I was working in Moss Creek Bridge replacement work for the Melbourne, and I've done some load rating of timber bridges for New South Wales, Australia, and yes, I've done some more work for M1 motorway extension for New South Wales. There is a overview of space gas and some coming slides. We'll start from the structure wizard. That's a good part of the space gas, that we can perform multiple tasks from by using wizard in space gas. Like we have trusses, we have simple beams, we have elastic beams on elastic foundations, and we have some plate modeling in space gas. We can easily perform some frame structures in space gas. We can, and there's some specialized wizard available in the for the bridges as well. Like this is the simple span bridge. This is for the skew bridges, and so on so far. These are the portal frame. So if when we are moving forward, we will just using the SpaceGas software, and I will interact on the my presentation as well. So if you can go through with the SpaceGas, there's a structure available for uh, single span beam, continuous beam, continuous with columns, beams on elastic foundation, trusses, boat trusses, some 3D multi-story frames, cylindrical frame, petal round models, multiple things that we can perform by using structural wizard, 2D, 3D wizard, and the portal frames. This is which a helpful part of the structure, SpaceGass. There are some more useful things available in SpaceGass, like we can perform linear static analysis, non-linear static analysis, buckling analysis, dynamic frequency analysis, spectral response analysis, and so on and so far. Dynamic frequency load, and we have load cases readily available for some certain kind of structures, like I've discussing previously, that we have wizard available in SpaceGass. We can perform wavefront analysis, like which is buckling analysis for the steel structures, and as well as for the other kind of structures. And it is another helpful thing, and you can check by your using, like, you have to perform buckling analysis first, then for design you have to check with on AS5100. Yes, because we haven't performed the buckling analysis, so it is giving me some error here. We can manage filters by selection in SpaceGass, which is a quite good supportive thing in SpaceGass available. And we can also import and export some Excel files, and um, some other structure, like you can easily import your CAD file as a structure line beam from the in only line model from AutoCAD to SpaceGass, and you can even merge your two structures by utilizing the merge facility of SpaceGass, which is another good part of the SpaceGass, and you can run also macros in SpaceGass. There are some extended features that are not included in some with standard software in SpaceGass. You have to purchase if you are performing plate element analysis, cable element dynamic frequency analysis. So you have to purchase these modules separately from the company, which is not included in the standard form of the software, which is, I think, sometimes helpful for if you are not interested to doing these analysis. So yeah, you cannot spending more money on that, but sometimes you need suddenly to perform this kind of analysis. So you have to have in your software, like in MIDAS, we have each and everything available. Yeah. If you talk about the limitation of SpaceGass, yes, there are some limitations in SpaceGass. We can perform because the SpaceGass is a multi-purpose structural analysis and design software for 2D and 3D structures, but some features that is that we cannot perform as quickly as possible in MIDAS, working in SpaceGass. There are some. So there is a list for these features that I have found working in SpaceGass. There is a when you're working in SpaceGass, there and you need to select to create a filter, like a number of elements. So in that case, sometimes we need to it give us like some errors. We will discuss these all three, like all of these index in few coming slide. So this is just like a go through slide. If you this is my first part, just like mentioning over here, filter selection. So I'm starting from here onward. So if you are working in SpaceGass, so sometime we have received this kind of error from SpaceGass, like too much selected members to fit in the filter list. So there I have create a video for that as well. Like can I can play for you guys. But yeah, we have some errors when we are working in SpaceGass. We receive some kind of errors in during selection. Uh, the other one is construction stage analysis. We cannot perform structure construction stage analysis working in SpaceGass. Um, we have some limitations in for such kind of structures. Like I was working for the monastery where, and we are extending the expand widening the bridge. So we have this is the old bridge, the east end of the bridge, and this is the west end of the other bridge, and we are expanding the width of the bridge. So in that case, and this is a two-span continuous bridge. So in that case, we must have to run some construction stage analysis for different stages. But when I was working in SpaceGas, so there was some limitations to perform such kind of operations. So I've just moved to MIDAS and I've performed all the analysis in one go. This is the bridge that I'm talking about. So this is the two-span continuous bridge. So I've tried to work on the SpaceGas as well, but somehow I was unable to perform each and every task in SpaceGas. So like we cannot easily perform this stage analysis on. I think you guys can see this video now. There is some. Can you guys see? Give me just a reply on this. Thank you very much. Yeah, this is the stage analysis while working on MIDAS. So this feature is extended to the MIDAS, that we can easily perform stage analysis while working on some continuous bridges or when you have more than one stages involved in your construction. Yeah, bridge testing. You can even perform pre testing while working on staging, but I don't think we can do this processing work on SpaceGass. Yeah, we have results as well. We are not interested in this staging, right? This moduling from right now. So we can move to our presentation. Yeah, can you? I think you guys can see my presentation now. Uh, Now we will discuss on the time-dependent material and creep and shrinkage. Uh, when working in SpaceGass, we have only we cannot apply creep and shrinkage as a material property in SpaceGass. However, we can apply uh, as a thermal load for creep and shrinkage. But in case of MIDAS, we have we can apply material. We can perform each creep and shrinkage in as good as possible in MIDAS, because we have we can give our master contents. We can give the concreting time uh, and we can perform a good creep and shrinkage in a good manner in MIDAS as compared with the SpaceGass. Uh, yeah, I have another video for time-dependent properties. I think I can play from here. Hope you guys can see this video. I hope you can see my video now. Thank you. Thank you very much. These features are not available in SpaceGas. We can easily perform our creep and shrinkage in using MIDAS. It is automatically create curve for the uh, strain curve for you. Now we'll jump on our presentation. Yeah. So there is another constraint working in space gas is a multi-linear spring. When you're working in space gas, there is only function available in space gas. It can um, we cannot perform py. We cannot put values of py curve in space gas. We have to give the stiffness values for the springs in space gas. There is no option available in space gas for having any other input from the user. So this is the major constraint when we have a number of files and we need to give the after each and every depth like maybe 500 millimeter we need to give some depth. So uh, in that case we need to perform give a lot of time for during modeling as compared to MIDAS when we have we can easily perform our multilinear spring function in MIDAS. So I have another video for because just to um, perform in on time because we have a limited time available. So that's why I put videos over here. But by any reason, these videos are not playing over here. So I am playing from my other screen. Right. I think you guys can see this video now. Uh, just make to fit in the presentation. Maybe the resolution is not as good as you can see from the other videos. So by using MIDAS, we can just easily perform these multilinear spring function like you can see from this video. We are giving the py values, and this is we cannot perform in space gas. We have to give the uh, stiffness of the spring only. If we have a 30-meter deep pile, so we have to put give the input for maybe 60 times on each abutment. So it will we can multiply this time to the number of supports we have. Moving load analysis. Uh, Moving load analysis is available in space gas, but still in very limited uh, functionality. But as compared to like when we are working in space gas, so we can apply moving load. Like I can demonstrate on over here. We initially we must have to divide the we have to divide the lanes our width to the number of lanes uh, by yourself manually. Then you have to create your scenario. For each and every scenario you will need to put your load for like in my case initially I have select the vehicle from the menu. Then I have selection of vehicle, then I have to create a path for moving load. So as I have created already, but I can make another path as well. Like you must have to know that which nodes you are talking, like uh, on which nodes you are trying to make a path for moving vehicle. Yes, you can provide some radius as well, and if you have a circular uh, and or curve bridge, but um, but it's still we need to perform if we have 3 lanes, so we can only run our 3 vehicles uh, by creating some certain load cases. But I cannot make a combination of different lanes. Like if I want to run lane 1 or lane 3 only, I want to make another load case for that. If I want to make my run my vehicle on 3 lanes consecutively, so I need to make another scenario for that. So for each and every scenario, I need to work like I spent maybe half an hour or more to make a scenario in SpaceGass. But in case of using other software like MIDAS, uh, I can show you my vehicle right now moving on the trailer on my deck. These are 3 lanes, but if I want to move my vehicle on uh, on a different pattern, with a different pattern, so I need to uh, create more scenarios, like uh, more than 3 or 4. But in case of MIDAS, we have a facility that it will make automatically combinations. So it is more convenient for the user. As the video is not running, I've performed this manually for in front of you. Yeah, bridge modeling wizard. Modeling wizard is a mighty feature of MIDAS. We have this feature available in SpaceGass, but you can see there are the number of structures available, uh, predefined structures that you can perform in MIDAS. Like we have suspension bridges, we have a cable straight bridges, uh, we have ILM bridges, FCM bridges, MSS bridges. Like a number of bridges we can perform using SpaceGass. But uh, but but in case of using SpaceGass, sorry, I'm talking about MIDAS, we can perform number of functions using the wizard modeler of MIDAS. But in case of SpaceGass, we have a very limited function available in our bridge modeler. Like we can only create uh, our grid lines and giving some constraints and section properties, not more than that. But here we have uh, when we performing on the midasCivil. So after completion of this visit, you have a complete bridge including substructure, your pile, piers, headstocks, girders, deck, pre-stressing. Each and every part of the bridge you can perform while using pre-stress function, like a visit function of MIDAS. But in SpaceGass, when you are doing performing on visit, so you are actually creating your lines, including the section properties, not even pre-stress, no loading. So loading is I think loading creation of loading is a main task while you're working on any structure, maybe in bridges or building. So but we don't have any loading functions available, preset loading available in this wizard function. So I think there there is a lack of uh, I cannot be I will not be biased here, but there are some constraints when you are using SpaceGass for especially for the bridge modeling of, and design fund. Uh, so yeah, it is a good software, but like I've said before, you can perform a number of tasks using SpaceGass, but when especially we are talking about on the bridges, so we are limited over here. Thermal action and its application in midasCivil. Yeah, we have similar function available in SpaceGass as well, but I'm just trying to um, put some your attention on some of the points. Like if I will show you the in my next slide the functions available for thermal loading in SpaceGass and the function available for in for the thermal loading in MIDAS as well. These are some MIDAS snapshots. You can provide the curve in MIDAS for the thermal the variation in from the depth from the top of the till bottom, but in SpaceGass you are unable to do. We have only this function available in SpaceGass, like input one thermal loading, which is linear function, and this is for the variation of depth. And when we are talking about for the MIDAS, so we have a number of inputs available for linear or non-linear. This is the linear non-linear temperature variation. This is the uniform temperature. So uh, it's a good part of SpaceGass, but still uh, it has some limitations. Combination of load cases. Uh, uh, you can use your MCT, which is midasCivil text file load cases preset. If you have create your single MCT file, so you can utilize this file to your number of bridges. You just import that MCT file for your new bridge, and it will work like for you don't need to put your extra effort and time for each and every bridge or structure. So as I said, there is a limitation. Use moving load envelope as a single load case to combine with other load cases in SpaceGass. Like you cannot use your moving load envelope to make another combination with the static case. Yeah, you can use it like your static case along with your moving loads, but you cannot use the envelope to uh, with other static cases. However, in MIDAS we can we can use the moving loads envelope as a static load to make a multiple load combination with other load cases. This is another good function of MIDAS that you can when you are working on SpaceGass, you have to put every time extra work and effort for to create these uh, load cases and combinations. But in on the other hand, we have preset load cases available for each and every time. Stressing in MIDAS versus SpaceGass. Yes, um, if we are working on pre-stressing, so we have this input available for pre-stress loading. However, on the other end, working in MIDAS, we have the like we can give the we can provide the profile for the tendon. We can give the uh, bonded and debonded length for the strands, and we can provide type of the strand. We can provide the strength of the strand. We can provide like whatever you input you have for the pre-stressing, you can put in MIDAS. But on the case of SpaceGass, we have pre-stress force. You can just provide the pre-stress force by calculating manually, and uh, you can do each and everything function in SpaceGass, but you have to perform your hand calculation or Excel spreadsheet working uh, outcome. So you can put that load over here. Otherwise, you just put your inputs, which is readily available from the drawings, or and over here, and you will be you will be like you have done. You don't need to put an extra effort for to calculating each and every strand values and their loads. I can show you on the SpaceGass. Pre-stress load. Okay. Right now, I'm using just like a break force for pre-stressing. This is the input which is available in SpaceGass for pre-stressing. Force category. So I'm not counting anything over here for the benefit of using MIDAS for performing the functions for your bridge or using SpaceGass. Yeah, I think we have done perform all each and every function, which is I can found from working in SpaceGas and MIDAS. But still, if there are some points which is we haven't discussed till yet, like I can go through from my slide. Yeah. Composite sections. Yeah, if you are working with some composite section, like you have a girder, and on the top of that you have a precast girder, and on the top of that you need to cast the slab. So using SpaceGas, you cannot it will not give you the composite section results while working on SpaceGas. But in MIDAS, you can easily perform your composite section operations while using their section modeler. It is another facility available in MIDAS that you can create your own sections, and you can easily import your CAD file as a section. And if you have a difficult section available, so you which is not available in the library, because we have a limited library for sections available in the library. See, I cannot go perform a composite action over here. I can just give the stiffness of my top slab, but I cannot I cannot give here the different material properties so that it will behave like a composite section. We have this section library available in the SpaceGass, but still if you are working on a different code which is not available in this library, and the section is quite difficult to prepare, so in that case we can import the section directly from the in MIDAS from the AutoCAD, but in this case in working in SpaceGass create uh, you cannot import your section. Yes, you can create your own by this function, by using this function, but still it is time consuming. You can perform each and every function in Spatial, but it is time consuming. You have to put extra time and effort to do that. But in case of MIDAS, you are just perform easily or just like 1, 2, 3. Mm. We don't have compression only springs in SpaceGass, and which is also available in MIDAS. In multiple cases, we need to have a compression only spring, but there is a constraint in SpaceGass that uh, we cannot apply these springs. So, in conclusion, I will just take some questions from the audience. Uh, yes, we have definitely we have uh, a huge difference in cost of both softwares, but like I've said, if you are working for bridges, so uh, because we have right now we in the industry we have a lot of work. Maybe each and every consultant has surviving just because of this mighty projects running in the industry, and this uh, like in this crashing resources time, we cannot put extra hours to uh, to to make our project unprofitable. So maybe it is a one-time cost for using this the other software, but it will definitely give you the positive results in eventually. So I think I've answered your question. Uh, as why we have chosen the SpaceGas as comparison with the MIDAS, like uh, MIDAS, this in industry, the other than MIDAS, the software which is uh, we are using for the design and analysis is SpaceGas. The whatever um, I've received from my past experience that every company is have to both of these softwares, but uh, just because of the other software is for the limited function available in the SpaceGas. So if we don't have that function available in SpaceGas, so mostly companies are working on other software for that specialized limited functions that is not we cannot capable to do in the SpaceGass. In our market, CSI is not using rigorously as compared with the SpaceGass. We are using SpaceGass uh, for bridges mostly in Australia, just because of the codes uh, are supporting in SpaceGass. But uh, SAP 2000 CSI software are not capable for working in what I think. I'm not commenting on this one, but I think CSI has uh, they don't have uh, Australian code in the this their software. Just as a SpaceGas is a user friendly. This is we can I can definitely say SpaceGas is quite easy to learn. The learning curve is very short as compared to Space MIDAS, but just we are performing each and every function on MIDAS, and we are not performing our op calculation in MIDAS. So there are some difficulties users are facing, because and what we are doing working in SpaceGas, we are actually calculating our loads manually or using spreadsheet. So uh, maybe some companies are confident on working on their spreadsheet and by hand calculations, but when we are using SpaceGas like MIDAS, so we are actually performing our load calculations or on the software as well. So it will take more time put inputting creating your model, creating your load cases, but it's a one window solution. You can perform your each and every task by working on software. You don't need, and even though the results of MIDAS are the reports are dynamic load reports, you can whatever you change in your model, you will found the changes in your report as well. So even though uh, like in Middle East industry, they are more concerned about the design calculation. So as a part of their design, so they need a complete compiled report for the design along with their drawings. So uh, it is the dynamic function of report creation of the MIDAS is also make it like it's unique from the other softwares. Other softwares have the their report function as well, but if we are working in SpaceGas, so and you are creating reports, so you need to snap each and every uh, uh, of your, like if you need to take your snapshot for the shear, your movement, your maximum hogging, maximum sagging. You have to spend extra more time other than your modeling for reporting. But if you are working in MIDAS, you don't need to put your extra time and effort for reporting. Uh, yes, load rating, but if you are like I have in past, I have done some load casing analysis. I have to check multiple loads for a bridge. So I have created maybe 7 or 8 scenarios, and each and every scenario I have more than 2 or 3 lanes, including patch loads. So multiplied by 7 into 3, 21 uh, running loads for a simple not combination. It's like running together all loads. So you need to put your load on girder. You need to put your load on mid span. So for each and every load combination, you need to create your, you need to put your extra time and effort, which is very time consuming. So I think you, for load rating, uh, still I will go with the MIDAS. I'm not biased here because I have done, I can show you my work, which when I was working for the load rating, and I have run 7 different lorries with uh, their different load cases, like 7 multiplied by 3 lanes with patch loadings. It's like a huge and if you are working maybe more than 4 or 5 structures, so you need to create that loadings and path for each and every structure as well. So but if you are working in MIDAS, so you need to import your MCT file, and it's all done. I hope I've answered your question. Uh, Mostly you don't need to put your extra hours in calculation when you're working in MIDAS. But yeah, still as an engineer, you must have some your thumb rules to check, verify the results of the MIDAS or each and every software. Like if you are working of space like MIDAS, SpaceGass, CSI, or StatPro or RM or whatever software you are talking about, you if what on whichever your software you are working, still you have some your sensitivity checks. You have some thumb rules to verify your results. We cannot, we as an engineer, we cannot blindly rely on any software, because software is whatever doing, we are giving input. If our input is wrong, so we are what we expect from the software, it will give us the wrong outputs. So outputs are dependent on the input. So if our input are, that's why we, if we engineers are doing work on this software. Otherwise everybody can do, if we don't have to calculate separate verification. So anybody can perform on or model like like just like a AutoCAD. So this is not a drafting software, which is this is a design and analysis software. So you must have some background and knowledge of to perform these tasks on this on the software. So software is doing nothing, just giving some calculation on the basis of our input. So we cannot rely on blindly the results of any software. I'm not saying MIDAS, any software, you cannot rely on the results blindly. Uh, yes, we in MIDAS the similar function available for rigid links and constraint. It's even easier than SpaceGass. I have worked on both software, so I can definitely say working on rigid links in my MIDAS is quite easier. And I think we are running out of time. So, and I hope I have answered each and every person. So in conclusion, I will say that both software are good, but there are some limitations for with each and every software. But in our case, SpaceGass has more limitations as compared with the MIDAS. Thank you very much for everybody joining us today, and for your time and effort. Hopefully, I will answer if I haven't answered here in the portal. So I will be answer your question separately by email. Thank you very much, guys. I hope you have enjoyed the session. Maybe some technical reason we were not able to continue our videos on the during the presentation, but yes, the uh, what we are were trying to discuss over here. I think the discussion was good, uh, and and healthy as well. So thank you very much.